Hey guys, and welcome back to Topic Tuesday from the Exilva blog. I'm joined here today again by my colleague Harrison. Welcome.
Hi, thank you.
Thanks for coming. Today we'll touch upon the topic of fibrils and fibers and its use in construction and concrete industry. And we're going to talk a little bit on the topic of how you could reduce the amount of synthetic fibers, for instance, by utilizing new technologies and rely less on petrochemicals. Going into a little bit what the situation is today, Harrison, could you fill us in on what typically are the technologies that's being used in the construction industry?
Yeah, so I mean, if you just look at like concretes and gypsums and you know the main types of construction materials, a lot of them need help to have the properties they need for the application.
Yeah.
And a lot of these focus around acceleration, so the speed up or the drying time or the setting time. Air entraining, so they have air inside the material to make it lighter or damp proof. Viscosity modifiers is another example where they increase the viscosity to help it remain on a surface, for example, easier. Or pumping materials, so that helps it flow better in a pipe, for example, or a spray. So I mean those are that was in the 20th century, 1950s, but a lot of those are petrol based, and a lot of them are inorganic compounds as well, like salts. But they have their own health hazards. They're not very sustainable, and they use petrol. It's not a healthy material to base your compounds on. What we're looking for now is alternatives. One of the first ones was fibers, either synthetic, glass, steel, or natural. And they have their own properties. They increase viscosity. They add structure to material. They can stop cracking, for example. They reduce weight. If they want, so air entrapment, for example, they help with that. However, they also have problems. Some are synthetic, so again, petrol-based, not ideal. You have glass fibers, but they have reduced strength. They're not good at keeping the compressive strength of a material. Steel fibers, they rust. So they have a short lifespan. And the natural fibers, they're very good, but they're hard to pump. For example, they're not the easiest. And you have to have a lot of machines to help you pump that material with the fibers in place.
So that's an historical picture of where the industry's been. I mean, since, as you say, since the 1950s and onwards, and even before that.
Today they're still using them, obviously, because they're the easiest option. But now we're looking forward to a more bio-based era with the construction additives. And those can be found with, for example, the nanocrystalline cellulose. Or the microfibrillated cellulose. Both have been used in the construction industry to an extent. But again, they come with their own issues. So, for example, the nanocrystalline cellulose, that even though it works and it can have an influence on the viscosity, for example, it has a tendency to clump together because they're very short. In structure.
So longer fibers, longer fibrils is actually a benefit.
Yes.
Can you explain a little bit why you think that's?
It's all to do, I think, with the mixing process of the material. When you mix it together, there's no. I mean, when you're mixing it in a mixer, concrete mixer, for example, there's no pressure on the material. It just the pressure you're shearing on the material is pushing it pushes the fibers along with it. But when it's short crystals, there's no give in the material to hold them in place, so they just clump together.
So what you're saying also is that if you've tried the nanocrystalline cellulose and seen that this clumps together, it could be an interesting innovation or test to actually test the fibrils instead.
Yes.
Interesting.
I mean, especially what we've seen with the lime video we did, it helps having a better dispersion.
Yeah.
You get a certainly more viscous and more uniform structure.
Yeah.
When you have the denser packing, you know, it can affect the cracking of the material.
Yeah.
Hydration, the setting time, and it's not good for the concrete, for example.
So where would you say, just finishing off the sort of this discussion, where would the industry move, or where should it move within the next, let's say, 10 years?
I think just to say getting rid of all admixtures, petrobase, is going to be hard. I think a lot of them are very good at what they do, but I think maybe reducing them, introducing these new bio-based, and gradually phasing them out would be a better option. Yeah, the microfibrillated cellulose does a lot of the things that the petrol-based ones do, and it's more sustainable, more healthy for the people using it and for the people who are around it the whole time.
Yeah.
So I think that's probably where it's going to be going.
Interesting. Yeah. I think we also have several downloads available on our web pages, and if you want to look more into this subject, feel free to contact us also on our webpage. So that's all for Topic Tuesday today. Thank you, Harrison, for being here.
It's okay, no problem.
Thank you for the interesting topic, and we'll see you next time.